Welcome to the Moon, our closest celestial neighbor. The Moon is not just a glowing orb in the sky, but a critical component for human life on Earth. It stabilizes our planet's axis, creates tides, protects us from celestial impacts, and provides a beacon of light at night. Beyond these practical roles, the Moon has also served as an endless source of inspiration, fueling our desire to explore and discover the unknown. Humans have already set foot on this celestial body, but the next step is far more ambitious: living there. So, sit back and buckle up as we delve into the awe-inspiring, complex, and monumental endeavor of building a base on the Moon. Before we shoot for the stars, or in this case, the Moon, let's take a moment to step back. The concept of a lunar base has been floating around since the dawn of the space age. Early initiatives like the Horizon Project aimed to build a launch pad for American nuclear missiles on the Moon. But as humanity has evolved, so have our ambitions. We transitioned from militaristic objectives to peaceful ones, shifting our focus toward permanent settlements. However, these ambitious plans were postponed due to high costs and technological limitations. In the 1960s, the space race was primarily a two-player game between the United States and the Soviet Union. Fast forward to today, and the landscape has dramatically evolved. It's no longer just about superpowers. It's a global endeavor with multiple stakeholders. NASA's Artemis program is ambitious, but they're not alone. The European Space Agency, Russia's Roscosmos, and the Chinese National Space Administration all have their eyes set on the Moon as well. But it's not just national agencies. Private companies are entering the fray. SpaceX, Blue Origin, and even smaller startups are looking at the Moon as the next frontier for both scientific exploration and commercial opportunities. Imagine a future where lunar bases serve as fueling stations for deep space missions, or as mining operations to extract rare earth metals. The stakes are high, and the race is on. This new space race is fueled by a blend of national pride, scientific curiosity, and the promise of commercial gain. It's a complex web of motivations that makes this era of space exploration both exciting and unpredictable. And unlike the Cold War era, this is a race that invites collaboration. International partnerships could be the key to overcoming the enormous challenges that lie ahead. As we discuss the future of lunar exploration, it's crucial to understand the timeline that's already taking shape. NASA's Artemis program has set ambitious milestones. In 2025, Artemis 3 aims to land the first woman and the next man on the Moon since 1972. During the following 3 years, subsequent Artemis missions will deliver essential elements for the lunar base, such as a pressurized rover, habitation modules, and power systems. Between 2028 and 2030, the assembly and commissioning of the lunar base are expected to begin. And from 2030 onwards, the first permanent astronauts could arrive at the lunar base. Other global players like the European Space Agency and China's CNSA have similar plans for the 2030s, but keep in mind that these timelines are subject to factors like budget and technology. You might be asking, why the Moon? Why not focus on Mars or other celestial bodies? The Moon offers several unique advantages that make it an ideal stepping stone for further space exploration. Firstly, its proximity to Earth makes it a more achievable target for current technology. A mission to the Moon can be completed in a matter of weeks, allowing for more frequent trips and the added safety net for astronauts to return safely in case of emergency. Secondly, the Moon's lower gravity makes it easier to launch spacecraft back to Earth or onto other destinations. This could be a game changer for future missions to Mars or even more distant locations. The Moon could serve as a spaceport where spacecraft stop to refuel and resupply, taking advantage of the Moon's resources to make deep space travel more sustainable. Lastly, the Moon itself is a rich source of scientific opportunities. From studying its geological history to setting up telescopes that can observe the universe without Earth's atmospheric interference, the Moon is a scientific playground that could fundamentally transform our understanding of the cosmos. So the moon is not just a lump of rock in space. It's a gateway to the universe, a testbed for new technologies, and perhaps even a new home for humanity. Getting to the moon is no small feat. Traditional rockets are expensive and can carry limited payloads, but the landscape is rapidly changing. Companies like SpaceX are revolutionizing space travel with reusable rockets, which could dramatically cut costs. The Falcon Heavy, for instance, can carry a payload of up to 63,800 kilograms to low Earth orbit, thereby opening up new possibilities for transporting materials to the moon. But it's not just about getting there, it's about getting back as well. The moon's lower gravity could actually be an invaluable advantage here. It requires less energy to launch from the moon than from Earth, making the return journey not only more feasible, but also more cost-effective. This could be especially crucial for missions that aim to bring back lunar resources for study or even for commercial use. Life on the moon is full of challenges. There's no atmosphere, which means there's no air to breathe or protection from harmful cosmic radiation. Temperatures at the equator can swing wildly, from a blistering hot 120 degrees Celsius in direct sunlight to a freezing cold minus 210 degrees at night. So how do we make the moon habitable? Advanced life support systems are crucial. These systems would need to recycle air, water, and waste. Imagine a closed-loop ecosystem, perhaps even leveraging biological systems like algae and plants to support long-term human habitation. Algae, for instance, can convert carbon dioxide back into oxygen and could be an integral part of the base's life support system. To mitigate the extreme temperature fluctuations, living in pits with shaded areas that maintain a temperature of around 17 degrees Celsius could offer a more stable environment. Water is another critical factor. The moon's south pole contains water ice, which could be mined and purified for drinking, used in agriculture, or even split into hydrogen and oxygen for rocket fuel. The Volatiles Investigating Polar Exploration rover, Viper, is set to explore the moon's south pole in 2024 to give us more insights into this precious resource. To build on the moon is unlike anything we've done before. The lower gravity, the abrasive lunar dust, and the lack of atmosphere are all unique challenges, but we're coming up with innovative solutions. One idea is to use 3D printing technology to build structures using lunar dust. This approach would drastically reduce the amount of material that needs to be transported from Earth. Inflatable habitats are another option. These could be sent to the moon in a compact form and inflated once they arrive, providing a quick and relatively easy way to establish a human presence. Lunar dust is particularly abrasive because it is made up of sharp, angular particles of glass and rock. These particles are created by the constant bombardment of the moon's surface by micrometeoroids and solar wind. The dust is also electrostatically charged, which can cause it to stick to surfaces and equipment. As a result, engineers must design new materials and protections specifically to shield spacecraft and technical equipment from lunar dust. Radiation is another significant concern. The moon's lack of atmosphere and magnetic field means that it's exposed to higher levels of radiation from the sun and cosmic rays. Potential solutions could include building habitats underground or using lunar dust as a shielding material. In fact, up to 2 meters of lunar material may be required to effectively shield astronauts from harmful radiation. Many of us grew up with dreams of humans setting foot on Mars. So why are we settling for the moon? The answer is both practical and visionary. The moon serves as an invaluable stepping stone for future missions to Mars and even further into the cosmos. Firstly, the moon's lower gravity, which is only about 17% of Earth's gravity, offers a unique advantage. Launching any mission from Earth requires overcoming our planet's gravitational pull, consuming enormous amounts of fuel. The moon's lower gravity could make it a cost-effective launch pad for missions to more distant locations. Imagine a future where payloads are sent to the moon first, assembled there, and then launched to Mars or even to asteroids and other celestial bodies, saving both fuel and financial resources. Secondly, the moon provides a proximate and practical testing ground for the technologies we'll need for Mars colonization. Life support systems, habitat construction, and even social dynamics can be tested and refined much closer to home. Mistakes, when they inevitably happen, are lessons that can be immediately learned and adapted without the dire consequences that could occur millions of miles away on Mars. Lastly, the Moon can serve as a research outpost for studying Mars and even for gaining a better understanding of our own planet Earth. Telescopes on the Moon could provide new insights into the Martian atmosphere, helping us prepare for the unique challenges that the red planet will present. As we stand on the cusp of becoming an interplanetary species, we must also grapple with the ethical and political implications of our endeavors. The Moon, often compared to Antarctica, is a shared human heritage. But who gets to make the rules? Who decides how its resources are allocated or how its territories are governed? The Outer Space Treaty of 1967 provides some guidelines, stating that celestial bodies are the province of all mankind and cannot be claimed by any sovereign nation. However, the treaty is somewhat vague on the commercial exploitation of resources, a loophole that could lead to a Wild West scenario if not carefully addressed. Moreover, we must consider the environmental impact of our activities. The Moon has remained relatively untouched for billions of years. Our presence could disrupt its delicate balance, posing ethical questions we've never had to contemplate before. Looking ahead, the Moon is more than a destination. It's a mirror reflecting our own values and ambitions. As we take these monumental steps, we carry the weight of ethical responsibility. Our actions on the Moon will set the precedent for how we approach the broader universe, making it imperative that we tread both thoughtfully and collaboratively. As we stand on the brink of this unprecedented new era, the possibilities are truly endless. From groundbreaking scientific research to the emerging potential for space tourism, the Moon could be humanity's next frontier. But it's not just about the Moon. It's about what the Moon enables us to do. Explore new worlds, harness previously untapped resources, and perhaps find new homes for future generations. Thank you for joining us on this journey through the challenges and possibilities of Moon colonization. If you found this video informative and intriguing, don't forget to like, subscribe, and hit that notification bell for more content like this. Until next time.